Okay, YouTube, this is my third video in my module over graphing quadratic functions. And in this video, we're going to focus on what we refer to as the vertex form of the equation of the parabola. Okay, so just like we have many different forms of, say, the equations of lines, we have many different forms, the equations of parabolas. And in this particular instance, we say vertex form is anything of the form. It looks like this. We say y equals, or f of x equals, a times the quantity x minus h, that quantity squared plus k. The things to point out about this form are, one, it's really awesome because it tells you where the vertex is, and two, the vertex is always at the point hk. If anybody's ever done anything with graphing in algebra, typically you've probably seen that this h value in here, you notice it has a minus in front of it, but h is responsible for, say, horizontal shift of our parent function. And it is a liar. You know, I mentioned here it is a liar. It is backwards. So, for instance, if we had the graph 2 times the quantity x plus 1, quantity squared plus 3, we would say the h value here is actually negative 1, even though it says positive 1. And the vertex being at hk, we say the k value is responsible for up and down shift here, but essentially that is the y value of our vertex. So just being able to identify h and k in these problems allows you to identify the vertex. Okay, cool. The axis of symmetry is the vertical line that goes through the vertex, and so it's a vertical line. It's an x equals equation. You'll notice that x equals h is the equation of our axis of symmetry, but it has to have the same x value as the x value of our vertex if it goes through the vertex. And then last but not least, we say the a value being positive would cause our parabola to open up. A value being negative would cause it to open down. And so we're just going to rock a couple of examples here and see how we can put this to use here, all of this information. But in the next two examples here, we're going to determine whether it opens up or down our parabola, tell whether the parabola is wider, narrower, the same width is the graph of y equals 1x squared. Identify the vertex, the axis of symmetry, and then we're going to sketch the graph is all we're going to do. So we'll take a look at this first example in the top right here. We say y equals negative a half, the quantity x plus 3 squared, that all plus 4. So the first thing we want to do is this. We want to identify a, h, and k. Okay, so we say a, our a value here is negative a half. So we say negative 1/2. Our h value, now recall h is a little bit backwards, so if it looks like plus 3, it's actually negative 3. And then we say it's shifted up 4. So positive 4 is our k value here. Okay, so we wanted to also determine whether this parabola opens up or down. We can see that our a value is negative here, so we'd say it opens downward. And also this, the fact that our a value is a proper fraction, that is, it's bigger on the bottom than it is on the top, okay, then this would necessarily imply that it is wider, and we're comparing here. So we say wider than the graph of y equals just a 1 times x squared, which is our parent function. Okay. As far as the vertex goes, we say the vertex was at hk. So if h is negative 3, that's our x value of our vertex, and k is 4, so that's the y value of our vertex. And then we say the axis of symmetry, the AOS, is at x equals negative 3. So to graph all of this, we just head over to our coordinate plane here. We say negative 3, 4 is where our vertex is at. In other words, this graph was shifted left 3 units, up 4 units. So we say from the origin 1, 2, 3, 1, 2, 3, 4. So here's the vertex on this parabola. Because I know it opens downward, I'm actually going to label this. You always want to label your vertex, but I'm going to label it above where my parabola is going to be. Oops, I wrote negative a half because I'm looking at the a value. It is negative 3, 4. Okay, we know the axis of symmetry runs north-south through the vertex, so we always want to drop this in here, drop that in. We say this has the equation x equals h, or in this case, x equals negative 3. And now, because our a value is negative a half, the important thing to note here is this. A is negative 1/2. A works as a slope, and so one would necessarily think, well, a is kind of like a slope. It tells us how to get from the vertex to one more point on our parabola. One would think that it would go down 1 right 2, and that this point would be on our parabola, and it would be wider because that's what, our point is. However, this is not the case. The a value, if I change this to a decimal, which is the practice you should be using here, you change this to negative 0.5, which means the same thing, and you put it over 1. Okay, what this means is this: the a value is always telling us, as our graph runs 1 to the right, how far up or down it goes. Okay, and so this negative a half implies that it goes down a half as it goes over 1. But the a value always tells us how far up or down it goes as our x value goes over exactly by 1. So in this case, it's going to go down a half. See where my pen is here? Down a half, right 1. Okay, and this will be a little bit wider than down 1, right 1. But we say since it went down a half and right 1, it's going to go down a half and also left 1. And then we can sketch in what our parabola would look like. And we notice it gets steeper and steeper as our x values grow either side of our axis of symmetry. Cool. Okay, so let's try another one here very, very briefly. We say, how about the graph of y equals 2 times the quantity x minus 1 squared plus 3. So we say start with this. A is 2. This is our A value here. H value. Now it looks like -1, but we know better. We say it's +1, plus 1. Our K value is plus 3. So in terms of what this tells us about our graph, the fact that A is positive means that it opens up, opens upward. The fact that it's 2 over 1, that's an improper fraction, we say skinny, or at least skinnier than a normal width, skinnier than y equals 1x squared. So we know these two things about our graph here. Next up, we want to say what the vertex is. The vertex is going to be at hk, so we have a h value of 1, a k value of 3. And the axis of symmetry, since it's a vertical line, it's x equals a number, and that number has to be the same thing as the x value of the vertex. Excuse me. So from the origin, we'll shift right 1, up 3. This is where our vertex is going to be. We also want to drop in our axis of symmetry and label this. It's always very important. So we say this is x equals 1, the same as the x value of my vertex. Since it opens upward, I'm going to label this underneath 1, 3. And since we have an a value of 2, now A is 2, same thing as over 1, okay? So we say it's going to go up 2 as our graph deviates 1 to the right. So we'd say up 2, right 1, this is on our graph. And this is why it's skinnier, okay? Because it goes up further than it runs, rises further than it runs. And it's symmetrical as well, so we know it goes through this point here. So we say, okay, so here's our skinny parabola with a vertex at 1, 3. All right, cool. So that's just a brief rundown of what vertex form is and how you would graph something from vertex form. Very cool.